Let's take a look at this example. Again, we're going to talk about the parallel circuit, which has two components connected together, resistor and capacitor. And first, we're supposed to find Z total. Please notice that we have given capacitance. In order to find total impedance, we're supposed to find capacitive reactance. So let's write the formula first for capacitive reactance. I have X of C is equal 1 over, and because I have given frequency, you're supposed to write 2 pi Fc, which is equal 1 divided by, open parenthesis, 2 pi times 1.6 megahertz times the capacitance 1.2 nanofarads. So X of C is equal 82.89 ohms and angle of negative 90 degrees. So this is the value of the capacitive reactance. Now, because we have resistance given and we have two components connected parallel, we can use the formula called the product over the sum. So I have Z total is equal R times X of C over R plus X of C, which is equal R 56 ohms times X of C, which is equal 82.89 ohms and angle of negative 90 degrees. Let me repeat myself over and over and over. X of C goes always with angle of negative 90 degrees or negative J if you are going to express this complex number in rectangular form, okay? But we are going to deal most of the time with polar form, that's why I'm going to use angles. So I have 56 ohms plus 82.89 ohms and angle of negative 90 degrees, close parenthesis, equals 46.4 ohms and angle of negative 34.04 degrees. This is the total impedance of my circuit. Next, I'm supposed to find I total. In order to find I total, I'm going to use the Ohm's law. I total is equal voltage source over Z total. Please notice that we are going to deal with the peak voltage. Why peak voltage? Because my voltage is expressed in terms of the sinusoidal equation. Okay, so this is my amplitude, and amplitude is nothing else just the voltage peak. So of course this is voltage. I'm supposed to write V over here. So voltage source is equal 24 volts over Z total, which is equal 46.4 ohms and angle of negative 34.04 degrees. This is equal 517.24 milliamps and angle of 34.04 degrees. This is the total current in my circuit. Next, we are going to find current which goes through the resistor and current which will go through the capacitor. But this time, instead of using Ohm's law, we are going to use current division law. Someone is going to say, oh, because Ohm's law is easier for me to use, I'm going to use Ohm's law. It's okay. If you want to use Ohm's law, it's okay, but I want you to practice also current division law. Okay, so we have IR is equal I total times Z total over resistance, where I total is equal 517.24 milliamps and angle of 34.04 degrees times Z total, which is equal 46.4 ohms and angle of negative 34.04 degrees over resistance, which is equal 56 ohms. Close parenthesis. Everything is equal 428.57 milliamps. An angle of 0. That's why I'm not writing any angle over here, okay? So this is the current which will go through the resistor. If you want to find the current which will go through the capacitor, you're supposed to write IC is equal, again I'm going to use current division law or the formula for the current divider. So I have I total times Z total over X of C. Okay, so I have 517.24 milliamps and angle of 34.04 degrees times the total impedance, which is 46.4 ohms and angle of negative 34.04 degrees over 82.89 ohms, my X of C, and angle of negative 90 degrees. Okay, so this is, one more time, this is the value of my capacitive reactance. Everything is equal 289.54 milliamps and angle of 90 degrees. We found two currents. Current which will go through the resistor and current which will go through the capacitor. Next thing which we're supposed to do is supposed to verify if the obtained answers are correct. So we're supposed to use KCL, Kirchhoff current law, which says that the sum of these two currents will give me the total current in my circuit. So I have to write I total is equal IR plus IC, where IR is equal 428.57 milliamps plus 289.54 milliamps and angle of 90 degrees. Everything is equal 517.2 milliamps and angle of 34.04 degrees. Now you're supposed to compare the result from the sum of these two currents and the result which we got from the Ohm's law, right? So we can see that these values are very close to each other. So it means that up to this moment we are okay with our calculations. Next we're supposed to find the angular velocity, in other words omega or radiant frequency. So write the formula first. omega is equal 2 pi f, 2 pi frequency. So I have 2 pi times 1.6 megahertz is equal 10.05 times 10 to the 6 radians per second. In other words, we can say this is 1 times 10 to the 7 radians per second. Both answers are correct. This one is a little bit shorter. Next, we're supposed to find the power factor. Power factor is equal cosine of angle theta. My theta was equal negative 34.04 degrees. Remember, theta is the angle which we have next to z total. So I have power factor equals 0.828 and of course lead. Why? Because the negative sign I have next to my angle, and also because the current in the RC circuit will always lead the voltage by certain angle. In our case, the current is going to lead the voltage by angle of 34.04 degrees. That's why I have word lead over here. As I mentioned earlier, it could be word lead, leading, or leads, but basically all of them means exactly the same. So next we're supposed to find the true power. P true is equal 1/2 of VR square over resistance. Now, someone is going to say, we didn't supposed to find voltage across the resistor. But you're supposed to remember that we are talking about the parallel circuit. In parallel circuit, the voltage is always the same, right? I mean, voltage is the same across each component. So I'm supposed to say that voltage source is equal voltage across the resistor, and this is also equal voltage across the capacitor. And in our case, this is equal 24 volts. Okay? And because I'm using peak value, I have to write 1/2. This is equal voltage across the resistor, we said, is 24 volts raised to the second power over 2 times R, and R is equal 56 ohms. Everything is equal 5.14 watts. Okay, so this is the true power in my circuit. Next, I'm supposed to find the reactive power, QC. QC is equal 1/2 voltage across the capacitor raised to the second power over X of C. This is equal 24 volts raised to the second power over 2 times X of C, which is 82.89 ohms. Close parenthesis. Everything is equal 3.47 volt ampere reactive. Okay, so this is the reactive power in my circuit. Next, I'm supposed to find the apparent power, S. S is equal 1/2, and I have voltage source raised to the second power over Z total, which is equal 24 volts raised to the second power over 2 times Z total, which we calculate was 46.4 ohms. everything is equal, 6.2 volt ampere. Okay, so this is my apparent power. Next, I'm supposed to find the series equivalent circuit to my parallel circuit. So what I'm supposed to do, I'm supposed to write again Z total. We found this, it was 46.4 ohms and angle of negative 34.04 degrees. You have to convert polar form to the rectangular form. And you will obtain 38.44 ohms minus J 25.97 ohms, where the real part is my resistance, Rs, and imaginary part is my capacitive reactance, X of C of S. Next, we're supposed to find the capacitance of the capacitor, which is going to be placed in my series equivalent circuit. In order to find the capacitance, CS, I'm going to use the formula for the capacitive reactance. So if X of CS is equal 1 over 2 pi F CS. You're supposed to use the algebra to solve this formula for CS is equal 1 over 2 pi F times X of CS. This is equal, so C of S is equal 1 divided by 2 pi times the frequency, which is equal to 1.6 megahertz. Okay, the frequency was given, and X of CS we found is equal to 25.97 ohms. So my C of S is equal 3.83 nanofarads. Okay, so I found the capacitance of the capacitor, which is going to be in my series equivalent circuit. So I have circuit voltage source, I have resistor, and I have capacitor also, where resistor has the value of 38.44 ohms, 38.44 ohms, and capacitance C equals 3.83 nanofarads. Okay, so we found impedance, we found the currents, we found powers. So basically we can say that the problem is solved.